All right. All right, I got it recording.
All right.
I'm not muted. Yep, locked it. All right.
It's 9:02. All right. I'm just gonna go ahead and get started. Since the beginning is fairly simple. Okay, so integrals. There are different kinds of integrals. The first one is arguably the simplest one to understand. It's integral with a boundary. And this is, for example, something like this, an integral of 2, and then lower boundary, upper boundary of 2, lower boundary of 1, 4x dx. But this can also be in any type of variations and combinations. So, for example, 3 and 2, like 3 upper bound, 2 lower bound. And that's what that boundary means, is that there is said upper and lower boundary, right? The next thing is the antidifferentiation with a boundary condition. And this is really where we get into the concept of the integrals essentially being the opposite of derivatives, what we had last class. And here we have the integral, this time without a boundary, as we can see, of 5x cubed plus 8 and dx, which turns into 5x to the fourth over 4 plus 8x plus c. And how that works, I'm going to explain now. So from the number that has the x to it, so the 5 in this case, we look at the exponent of set x. We essentially do that x plus 1, 4, and then divide it by that exact same number. Hence, we get said combination of 5x to the fourth over 4. The 8, we then add an x to it. Since, like I said before, we're essentially doing the opposite of what we did last class. So in derivatives, for example, we do 3x squared. We then do 6x. If we only have an x, then essentially that x just gets crossed out because 1 times anything. You get the idea. And so in this case, instead of not having the 8 anymore in the first place, we add an x to it, since 1 times 8 is 8, right? And then we have plus c, and the plus c essentially just stands for any variable that comes after that. And we have to write that because as soon as we do the antiderivative of this equation, we have the last number, because if we take the derivative of a number, then the number without the x, we don't write that anymore, hence seen in the equation.
Okay, did y'all understand that part of why we do plus c?
Yeah, I don't know what else would be there. So it's like that. Yeah.
Right, because when you take the derivative of constant, if it doesn't have an x, it goes away. So it could be 0 or it could be 5,000, whatever.
Right. Okay. And to represent that variable, to represent the number that we don't know that it exists, we write set c. Okay. Not only this, but any other part. Any questions so far? Cool. Okay.
One question.
Huh?
For the boundaries, it's a horizontal boundary on like a y value, correct?
Yes.
Okay.
Like
a y equals kind of boundary.
Well, yeah, actually,
for like the upper and lower boundary being 2 and 1, would it be like y equals 2 and then y equals 1?
Yeah. So wait, actually, it's more or less it's. I was trying to show you some. So, it's more so actually a x value boundary, as we will also see in the area of a region section.
Not like this.
Yes.
Vertical, like a vertical.
That is vertical. Yeah, vertical.
Okay.
Okay. So next section we have is the definite integrals, and this is actually really similar to the boundary ones. And this is the basic equation, and you can, just like with the boundary condition, you can essentially plug a number in so a, b, and then f of x. So in this case, f of x is equal to 7x, and then the a is 3, and then the b is 1. So yeah, that's kind of just that is the integral, that is the definite of it. If that makes any sense? Cool.
Leonard, can you zoom in?
Okay. Yeah.
That's embarrassing.
How dare you, Rohan? All right. Better, Rohan?
Yeah, thank you.
All right. Okay, so next is one of the bit more difficult lessons. That's the area of a region enclosed by a curve I is f of x, and the x-axis, there's text after that, where f of x is greater than 0. So let's take, for example, the function of x squared. This will turn into the function of x cubed over 3, and how that works, I'm gonna show now. So the best way to find the antiderivative of this is to actually take the x and then the exponent offset x, and then add a +1 to it. So x cubed in this case. Then we take the derivative of that, 3x squared. And now you have to ask ourselves, what do we have to do to this 3x squared to make it x squared divided by 3, because 3 divided by 3 is 1. So therefore we do 3x squared over 3. And what we have to do one side, we also have to do to the other side. So x cubed over 3, and that obviously equals x squared, because 3 over 3. And and that's why x cubed over 3 is the antiderivative of this the function x squared. Does that make sense?
Yes. I don't think so.
What part are you kind of there? Like what part can I make it clearer?
So you're saying you add 1 to the exponent and you divide it by the new exponent number. So you have x squared, so you add 1 to the exponent and divide it by 3. And is that it?
Well,
and that's equal to x squared, which is the original number.
Okay. So for this function, you need to find the antiderivative, because that's an integral at the end of the game, right? In order to do this, the best way to do this, or the easiest per se, is to add 1 to the exponent x cubed. Then you take the derivative of that function, that becomes 3x squared, and then that derivative function needs to get back to x squared, because that's our actual original function. And how do you do that? Divide by 3, because 3x squared divided by 3 is x squared. That's our original function.
So like if you add 1 to the exponent, doesn't it become x cubed? Like am I just like missing something?
It was x squared originally.
Yeah, I got that.
Yeah. So then the x squared, you add 1, it becomes x cubed divided by the power, so it would be 1/3 x cubed.
Yeah.
Yes.
So then how do you get to x squared by dividing 3? That's where I got you take the derivative of it.
Yes.
And you divide it by 3 to get x squared again. But aren't you just doing like nothing there? Like you're just starting again at the beginning.
I think. Are you saying this is how you like check it?
Well, more or less, yes. This is how you get from This is how you get from lowercase f of x to uppercase f of x, like to the antiderivative of that function. Yes. Or am I doing something wrong?
Okay, where are you?
Okay, so
you're here.
Yeah, I'm trying to explain this. And
okay, so you start with from here up.
No, this is the explanation.
I think you're showing them the opposite. He's also saying this is. I think what he's trying to say is this is how you're checking your work. So like because it's the antiderivative, from here, if I start with x cubed over 3 and I take the derivative, what's the derivative of x cubed?
3x squared.
When I divide 3x squared by 3, what do I get?
X squared.
So that's how you check your answer at the end, is you can take the derivative to double check. I personally think that y'all are much more proficient in taking derivatives than making integrals. So after you make an integral, I encourage you to take the derivative really quickly to double check that you did it right. If after you make your integral and you take the derivative, you get the original question, you did it right. If you don't, you messed it up somewhere. Okay.
All right. So from here, we have the integral of upper boundary 3 and lower boundary 1, and then and so I kind of tried to make this a bit easier to do highlights. So the blue ones, so kind of those correspond to each other, like the x squared. So that goes back to our integral function. So x squared is equal to, and now we use our new f of x, the x cubed over 3, right? And then we have now that boundary essentially of upper boundary 3, lower boundary 1, as we see here. So kind of these two numbers then correlate. So now we plug both numbers in. So 3 cubed over 3, and then 1 cubed over 3, 27 over 3 minus 1/3, 8.67. So essentially just plug both boundaries in.
What does that give you? Like, why do you do that?
Oh, that gives us the area of a region.
Okay.
So far, so good.
You plug in the values of the given boundaries.
So are boundaries, okay, I just have one question about boundaries.
Sure.
Yeah.
Are they always going to be given, or do you have to solve and find for boundaries?
It depends on the question. Typically, they're going to be given. If it's a question where you have 2 lines and you're finding the area between a curve, you find the boundaries by calculating the points of intersection between those 2. The other situation is they may give you one boundary and tell you what the area is and ask you to solve for the other boundary.
Okay. Is this one like delta naught?
Yes.
Some of it.
Yes, I did not record the review yesterday. My YouTube page, I'm teaching integrals to the juniors right now. So also if you want to just go and watch those videos as well, I just retaught derivatives and integrals.
Thank you.
All right. Any other questions on this part? All right. Cool. Okay. So next we have in definite integrals, and this is these are the definitions of those integrals. So that's what they become. So sine of x becomes dx d over dx negative cosine x cosine sine 1 over x becomes x to the negative first. Ex becomes d over dx e to the x. You can read it. Can you? Right? Yeah.
So if dy dx is the derivative.
Mr. Yuki's office.
So if what does the d over dx notation mean?
Huh?
What does the d over dx notation mean?
The d over dx notation essentially means that you then check it, then check this by taking the derivative of it.
Could you like do an example? Because I mean I'm really confused on like
like if dy dx is the derivative, what is d over dx?
Okay, time out. Really quickly, I would like to believe that if I were up here teaching, most of y'all would not have your computers out and open, typing and working on other stuff. Okay, just double checking. I mean, if you're looking at what he's doing, that's one thing, but like, I know that y'all are good at multitasking, but it's not a conducive review if you're not all paying attention. I appreciate those of you that were. Okay, so when we have ddx, it is sometimes just a different way of notating, but at the end, are y'all talking about this dx here at the end?
No, they're talking about the indefinite values.
It can be dy dx as well. So when you have those sine of x, okay, the reason why is it's a little bit different of a notation. What you need to keep in mind with integrals of these transcendentals is of the trigonometric functions and the e to the u, the weird ones, is remember that on your formula sheet, it says sine of the derivative of sine of x is cosine of x. But what I taught you is that the derivative of sine of u is cosine u times du. You have to take the derivative of the inside. So I think this notation is also trying to incorporate u substitution, which is where you have to keep in mind that if there's something other than x in there, that you have to factor that in. If we're reading this just as sine of x, the derivative is cosine of x.
And so the integral of sine of x is negative cosine of x.
Yes. So when I take the derivative of cosine, what do I get?
Negative sign.
Negative sign. But if I want it to become positive sign, it would be,
Integral.
I have to put the negative in front. So like when I'm thinking backwards is if I have negative cosine of x and I want to take the derivative of this, then I end up getting negative times negative sine of x, which is then positive sine of x.
So let's say it's like sine of like 5x squared. Like how would you solve for the integral of that?
Okay, so when I have u substitution,
Yeah.
might as well put it in the video, right? Okay, so when I have u substitution, if I have sine of 5x squared, if I want to integrate this, I taught it to y'all, I think, outside, inside, or ugly, right? What part of this is ugly? What part of this do you not really want to do? The sine or the 5x squared?
The sine.
The sine part, like that's gross. I don't want anything to do with it. So whatever is on the inside of the ugly part, we want to make it look prettier. Sine of 5x squared sounds a lot more complicated than sine of x, right? So instead, I'm going to change this into sine of u. But there's a dx at the end in respect to x. But now I've changed the variable. Now I need to do this in respect to u. So I need to define what u is. We said it's 5x squared. The next step is to take the derivative. So du dx is what? Now, here I have a dx. I need to solve this for dx. So if I solve this for dx, this is the same thing as 10x over du. So now here, instead of, yes, sorry.
Oh.
Du over 10x, there we go. Here, and then I would have du over 10x. Then I can integrate it knowing, normally, I'm just gonna tell you right now, normally there's like an x in front of this to make it pretty. So here, my x's would cancel. If I have a constant, I can pull it out. So this is the same thing as 1/10 integral sine of u du. So now I know that the integral of sine is negative cosine u. So now I have 1/10 times negative cosine u plus c. I plug back in my u. My final answer would be negative 1/10 cosine 5x squared plus c. Now I know all of that is super complicated, but at the end, if I'm having my doubts, I can take the derivative of that. When I take the derivative of cosine, what do I get? I'm going to do this one on the board just because.
Negative sign.
I have negative sign. So I would have negative 1/10 times negative sine of 5x squared But whenever I take the derivative of one of these, I also have to multiply times the derivative of the inside, so times 10x. And then I end up getting 1/10 sine 5x squared times 10x, and then I end up getting x times sine of 5x squared. Look, it's the problem that I had originally.
Wow.
What's that?
For the after you have the 1/10 integral sine u du, where does the du go? Does it just become the
From here to here?
yeah. Does it just become the c?
Yeah.
Yeah.
Du really means in respect to u.
It's not derivative u.
No.
No.
Thank you.
Or it is derivative of u, and then you integrate it, and it's gone.
Where is it?
Yes.
Okay.
Thank you.
Okay, does this section now make sense for everybody?
Yes.
Thank you, Leonard.
All right. The last section is so I tried to put this in the simplest words. So I'm going to zoom in on this so you can see this better. There we go. Oh boy. All right, this is as big as I can put it. Can everybody see this equation or no?
Yes.
Cool.
Love that equation, Leonard.
I didn't make it up, it's math. So this is also for an area of a region close by curve y of x. But this time the f of x can be positive or negative, okay? So it's a bit different, as you can see. Without reading all of this out, because that would be probably a waste of time, I'm just gonna go over how to actually do it. Let's take, for example, the integral of pi over 3 upper boundary and the lower boundary 1. And we have, let's say, cosine of x dx here, right? As we know from our indefinite integrals, we have, which gives us sine of x. And then we essentially log it into the equation again, like we did for the last one, for the last area of region, right? We plugged the upper, lower boundary in and subtracted. So sine of pi over 3 minus sine of 1, lower minus upper. And then we get the number, you can see it. Yeah, that's the simple version.
That's not the answer. You wrote out the number. Can you put the answer?
Scroll to the right.
Oh, there. Oh, thank you.
Yeah, you plug in the upper boundary to the x value, plug in the lower value to the x value.
After taking the
Sorry, it's all right.
So you take the integral, Leonard, like I just want to make sure you take the integral and then you do upper minus lower for that, what you got for the integrated value, right?
Yes, yeah. So you essentially, so you see you have cosine x here and sine of x. You integrated that to get sine of x, and then you plug in upper minus lower, hence our upper minus lower upper and lower values, and then you get the number that you can see on screen. That's a simple way of putting this whole mumbo jumbo into action.
Let me stop the other question about like on the IB exam. How would you just express that as like 0.0008 or like could you just leave it as like
0.00?
Yeah, I mean not that, but like just 0. Right.
To be fair, I don't think they would give you an answer that does this.
Okay.
In which case, 3 significant digits. In this case, it's not. 3 significant digits to me would be saying what he like 824 is the rounded.
Okay.
I mean,
Would you have to do
To be
like?
fair,
you shouldn't have to do that. Make that choice.
To be fair, I just
if anything, the other thing you can always do on IB versus Again, this one's not perfect,
Hmm.
air quotes, but you would do something called exact value would be the other thing that they would be asking for. So in the case of plugging in our boundaries, the boundaries were 1 and pi over 3, which are values on your unit circle. You should know what those are in exact value. So for pi over 3, sine of pi over 3, 1/2 comma square, it would be square root 3 over 2 minus sine of 1, which is maybe not an exact value, but normally they would give you like an exact value. So when you leave it in terms of exact value, you don't have to worry about rounding.
I just make these values up in my head. Like I didn't run them through if they would work or not before I ran them, and then that gave me that number. So in the actual IB exam, hopefully it's gonna give us some a bit better numbers. Okay. And yeah, if you're interested to see the graphs of these two, this is how they would look like. Okay. Yeah, that was the review on integrals. Hope it was somewhat helpful. Okay, so now to the review game. Okay, I'm gonna need you guys to get in groups of 3. You guys can decide your groups.
Keep our same group for the cheat sheet.
Okay, so we just.
As long as you, wait. Well,
No, we don't.
I was just wondering.
No, we don't.
No, hey.
Pick your groups, go. You're your groups. Go down my here. Circle part 5. Wow. We're better than 5.
That's your spot.
No.
We have 10, so we get Andrew.
Huh?
Stuck in your shirt, bro.
We can't have 3 groups of 3 because we have 10, so we're gonna take Andrew.
Andrew on our team.
Oh, wait, what?
There's 10 of us.
Wait, what about the hunt?
Monsters with this.
There's
There's 4.
you need a group of 4.
Yes.
Yeah.
There's 10 of us.
Okay, so my game is similar to the last groups, but not completely the same. So I also have some dares, but mine is I have 5 problems, and whichever groups get it first get to decide what the last group has to do.
Oh.
Whoa.
All right.
Maybe you don't have paper.
I'm gonna need a pencil and a pen and a paper.
All right.
Okay.
So,
Hey, Leonard, like you're just not ready.
well, actually, yeah. Maybe just quickly.
Leonard, where are their answers?
Wait, just quickly. Okay. So, the second point. So once you solve the problem, there are 3 possible answer choices. These answer choices all spell out these all 5 letters. They spell out a word, and the first and that's essentially how I know that you got it right or wrong if you got the word right. So that the first groups to get the word right get to decide.
I have a question.
That's
Is it
amazing.
your whole group that's the answer, or 1 person?
The group.
I mean,
That was a weird question.
No, but Leonard, let's say like you get it right and you're not done. Can you say the answer for the group?
Yes,
That's what I'm
how
saying.
group things work. It's like if one person shoots a basketball and then the player
Just-
for the whole team.
I don't play sports. I don't know what you're talking about.
Really quickly on your Google Classroom page, I'm posting
I have it on this. I have it on
the link to the YouTube playlist for the juniors and adding their review for their tests. Next week, they will finish taking their tests. I will also add their tests over integrals on there as well. So you can have more IB style questions as a review on there. But I mean, you'll also have plenty of mock questions as well.
Okay. Is every group ready?
Yeah.
Is everybody ready?
Hold on, 1 second.
Okay.
All right, hang now.
All right. And the first groups to get it, get to the side. And here we go.
Answers are there.
Yeah. You
Okay.
get to choose. That's what I explained.
Scroll in more, zoom in more.
Okay.
Wait, what?
That's what I explained to you. You spell out a word with these answer choices, and then you always need to take like the right answer.
Why
do the answers go C, G, B?
Because
Why
you
are
spell out a
you
word.
listening to the direction?
Oh,
it's
that's what's spelling the word. Okay.
Okay.
What do you think, Mikkel?
like literally
Yeah.
just answered the question.
Oh.
Is it bad that I'm trying to get this?
I mean, you. Okay.
Wait,
Leonard doesn't spell boats.
Okay, we got it.
Huh?
We got it.
Leonard boats.
Okay.
Is in G.
You have to do the whole thing.
The
Yeah.
whole thing, like all of them?
Yeah.
I thought
Yes.
yes. Line.
Yes. They all of these problems spell out one word.
Does it spell?
Okay, I know what the word is.
Okay.
No,
Actually,
you don't.
actually,
you.
actually, write on the paper. so
Okay.
I think it's-
Wait, do you wanna
Oh yeah, we do. Yeah, you're right. Go.
Let's-
No, go, you got it, you're right. I know what you mean.
Is it this?
Do you actually?
Yeah.
Is this the one?
Yeah.
Leonard,
Leonard, we got it.
we have it, Leonard.
You guys need to do the questions.
That's what I'm doing. right now.
Just.
That's what I'm doing right now.
All right. Yeah, you got it.
Your group, I'd like to see everybody do the math, but then I guess y'all are gonna be responsible for explaining.
That's what I just said, like, we can't. If one person in our group says the answer, does it count?
Leonard, move.
Sorry.
Oh, so now it doesn't count.
That's much work. I know. Okay, I got it.
Okay, I mean, no problem, I guess.
Okay, come here.
God, man. So I'm supposed to do like
13x plus C.
Oh.
Is it 9x to the fifth?
Wait, Liz.
I
Did you
also
do- did
just
you do
added
last
to
time?
Google Classroom,
I was
take
just like-
home docs for derivatives and integrals, they're both paper ones, meaning without a calculator.
Hold on.
I kind of just wrote it down. I haven't really done the math. I did it on my head. Like, I'm
Yeah, Liz.
Hey, man, you said I got it though.
Okay.
No, they just guessed the word.
Okay.
Go show the math.
I'll fix that right now, Leonard.
Leonard, do we have?
I can explain the math if you want.
No, we only have one.
We have a,
Liz, you have it.
Okay,
Yeah.
And then Joaquin has explanation.
I'm sorry.
Okay.
Can you come?
Do we have to take the derivative?
All right.
We'll have the second one. Do we have to take the derivative? Which one?
No, it's.
Yeah, you're right.
Which one?
It's like so you solve for the integral.
I know, yeah, it's like, oh, stop.
I was telling her how like poorly y'all did, like everybody did on the statistics one thing. You're welcome.
Which one?
And she goes, do you think everybody in my group will do that bad? And I'm like, yeah.
You said it was right. We didn't have to do the word. Anyway, Jackie, which one are you working on? Did you just do two? I'm trying to understand it. Okay.
Wait, oh, never mind. I don't think it's there.
Oh my gosh.
Right.
Okay.
I would do.
I have a question.
All right, you got it.
8 and 3.
Thank you, Leonard.
All right, two groups have got some. Got nothing.
They actually have gotten it. They just can you just
Yeah.
No, we got it.
I already explained it the best if you want.
No, but Rohan will be speaking for our group.
No, it should be 1.
We got it right, so that's all that matters.
1 6 x to the 6.
Yeah.
Yeah.
Okay, and then you put so
I'm not a kid.
Leonard, do you want me to explain? Huh?
minus
Dude, let everybody figure it out.
Yeah.
You can then explain it.
Okay.
Sure. Sure.
Oh, yeah.
You want to
Sorry, I was like, it's fine, you can do it.
I don't know.
You did. Is that what it says right there?
James.
I don't know.
Can you explain it?
You made it to the
the 6th up here.
That was more.
No, look.
Okay, I'll do it for the 6th too. Like,
Dude. Like,
I like.
um,
Which one are you talking about? Is there anyone who could do-
actually win?
You know what?
Huh?
I'll
We
do
win every
five.
day.
I'll do 5.
Liz, did you find out?
we just need a word, Leonard. No doubt.
Yeah, basically.
So
I think I can explain most of them.
Yeah, I can explain
Technically,
all of them.
got it first.
Oh,
Okay.
dang.
Leonard, I can explain. Wait, I can explain.
I can explain all of them except two.
I can explain.
I can explain
What
too.
you explained all of them.
Wait, Ron, are you
Yeah.
listening to the same group?
Yeah.
Yeah.
Okay. I can explain.
Looks like you guys got last.
Oh, dang.
Yeah, I'm not getting the right answer.
That's right. Like
Yeah, that's right. This answer.
this answer is right. Okay.
Wait, let me see the answer.
I just tried to answer last night.
We
Yeah,
figured out.
Number 2 you did wrong.
Oh, okay.
Yeah.
That's actually the one I. Okay.
I'm sorry.
I thought you
Number
were
2
supposed to
should
put,
be
like,
1/6 x to the 6th,
Mm-hmm.
and then you plug in the 8 and 3.
I got.
Like none of those values.
Yeah. Wait. Why
And
did
then
I?
it's plus.
Okay. Okay. For some
I
reason-
think you plugged into the 5th.
I didn't. But okay.
Play one.
Weird.
That's okay. Hey, did you stop recording?
That is a very good question.
No, you're still recording.
I would stop recording, but